Hello everyone, welcome back to our Python programming series. In today's video, we're diving into one of the coolest features of Python, that is nested functions. But what exactly are they? How are they different from functions in other programming languages? And why should we care about them? We're going to explore these questions step by step with plenty of examples, so stick around. In Python, a nested function is simply a function defined inside another function. This means that a function can be used as a building block for other functions. This behavior is not unique to Python, but Python allows such functions in a very clean, intuitive way, and we're going to take a look at some real world use cases. So imagine we have a function that performs a complex task, but you only need a small piece of it in the middle of that task. Instead of cluttering your code with unnecessary functions, you can define that smaller piece right inside your main function. We'll take a look at simple example. Here's how a basic nested function looks in Python. We have our main function and inside it we define another function. In this example, we have outer function which contains another function called the inner function. The cool thing here is that the inner function is only available within the outer function. When we run the code, and when we call for the outer function, the inner function gets called first, and then the outer function prints its statement. So let's break it down. When you run this, you get the following output. Now, you might be thinking, hey, these are not Python exclusive features, and you're right, other programming languages also support such functions. But what's unique about Python is how it handles scope and how easily nested functions are integrated into the language. In many languages, such functions can often feel like a hack or an afterthought, but in Python, they're deeply integrated into the language's structure, making it possible to achieve elegant solutions to real world problems. We'll see how this plays into practice. One of the most powerful features of such function in Python is the concept of closures. A closure happens when a nested function remembers and has access to variables in its containing function, even after that containing function has finished executing. Here's what's going on in this example. We define outer function x, which takes the parameter x. Inside outer function, there's an inner function y that takes another parameter y and then adds it to x. Now here's the magic. When we call outer function 5, it returns inner function, and inner function remembers the value of x even though outer function has finished executing. When we call add 5 and then pass the parameter 10 to it, it adds 5 from the outer function and then 10 from the inner function, and the output is 15. Notice how the inner function is able to access x, even though it was defined in our outer scope. This is a prime example of how closures work in Python, and it's something that makes Python's nested functions incredibly powerful and flexible. Now let's talk about the real world use case where such functions shine. Encapsulation. Sometimes you don't want certain functionality to be accessible outside of a function because it's not needed. This is where such functions help keep things tidy and avoid polluting the global namespace. Say we are working with an application that involves processing user input and calculating the results. We don't need to expose every helper function to the outside world, only the ones that are essential. Here's an example. In this code, we have a process input function that performs two tasks. It validates the input and processes it. The validate input function is nested inside process input and is not available outside. If the input is invalid, we return an error message. If it's valid, we double the input and return it. When you call the process input and pass and string argument 10, it returns 20. And if you pass process input and string argument ABC, it gives us the invalid input message. This is an example of how nested functions allow us to hide helper functions from the outside world, making our code cleaner and more secure. Now, why would you want to use such functions? Here are some key advantages. Encapsulation. As we saw, such functions allows us to keep helper functions private to their parent functions. Another is maintainability. If a function only makes sense within the context of another, keeping them nested keeps your code cleaner and easier to understand. And the last one is access to outer variables. Nested functions have access to variables from their outside functions, which is handy when you need to keep state between function calls. However, like all things, such functions have their own limitations. First, because inner functions can't be accessed from outer. First, the inner functions can't be accessed from outside the parent function. They may limit reusability. Also, too many such functions can make your code harder to follow if not used carefully. So always try to find a balance. So there you have it, nested functions in Python. They might seem simple at first, but once you understand closure, encapsulation, and scope, you'll see how powerful they can be. Whether you're keeping your code clean, hiding functionality, or taking advantage of closures, nested functions are a tool every Python developer should master. So, thanks for watching. Don't forget to like, subscribe, and hit that bell icon so you never miss an update. If you have any questions or examples of nested functions you've used, drop them in the comments below. I'd love to hear from you. Until next time, happy coding.